All right, let's talk about artificial intelligence. We're going to cut through the noise and build a really solid understanding of what it is, how it actually works, and most importantly, why it matters so much right now. I mean, you see it everywhere, right? You hear about it constantly. But when we get past all the headlines and the hype, what are we actually talking about when we say AI? Well, that's exactly the question we're going to tackle.
So first, a little perspective. AI didn't just pop up overnight. The actual term, that was coined way back in 1956. And from there, we had these huge landmark moments, like in '97 when IBM's Deep Blue beat the world's best chess player, or in 2003 when NASA rovers were driving themselves around on Mars. The point is, this has been decades in the making.
So with that history in mind, let's build our foundation. It's time to get past the buzzwords and get to a real, concrete definition of AI. When you strip everything else away, this is it. AI is the science of making machines do things that, for the longest time, we thought only humans could do. Things like seeing the world around them, learning from experience, and making tough calls. Now, and this is really important, not all AI is the same. Understanding this next part is absolutely crucial for separating the AI we actually have today from the stuff you see in sci-fi movies. So let's break down the 3 tiers of AI. So first up is artificial narrow intelligence, or ANI. This is basically all the AI that exists in the world today. It's built to do one single thing really well, whether that's recommending a movie or filtering your email. Then you've got the stuff of the future, AGI, an AI that could learn and adapt just like a human, and ASI, a purely theoretical AI that would be smarter than us in every way. The main takeaway here, we are living 100% in the age of narrow AI. So how does this narrow AI actually learn to do its job? Let's pop the hood and take a look at the real engine driving modern AI, machine learning, and its even more powerful cousin, deep learning. Machine learning is where this whole modern revolution began. It's all about using stats to find patterns in data. But here's the key. A human has to basically hold its hand. To teach it to identify a cat, for instance, a person has to manually program in the important features, like pointy ears or long whiskers. And this is what leads us to the next massive leap forward, deep learning. The easiest way to think about it is as a trade-off. Classic machine learning is way easier to understand. You can usually figure out why it made a decision. Deep learning, on the other hand, gives you incredible performance, especially with messy, unstructured stuff like images and text because, and this is the game changer, it figures out the important features all on its own. Let's dig into that a little more. All that power from deep learning, it comes at a price. It needs absolutely massive amounts of data and some serious computing power. We're talking a ton of GPUs. And in exchange, it learns all those features automatically. But look at that third row. That's the crucial trade-off. As the performance goes through the roof, our ability to understand how it's making decisions just plummets. And that drop in our ability to interpret things leads directly to this, the black box problem. With so many of these powerful deep learning models, we can see the data that goes in, and we can see the answer that comes out, but the process in the middle is so complex, it's a black box. And that's a massive problem when it comes to things like transparency and accountability. So all of that really sets the stage for the technology that is completely dominating the conversation today, generative AI. We're not just analyzing data anymore. Now we're creating things that are completely new. I mean, the clue is right there in the name. Generative AI generates stuff. It learns all the patterns from a gigantic data set, and then it uses that knowledge to create brand new content. You give it a prompt, it gives you back new text, a new image, or even new music. And there are really 2 key breakthroughs that are making this all happen. For text, it's something called the transformer architecture. This is the engine inside every single large language model you've ever used. For images, it's diffusion models, which have this amazing method. They basically start with a canvas of pure static, like an old TV screen, and then slowly carve an image out of the noise. So the transformer's secret weapon is this brilliant mechanism called self-attention. See, older models had to read a sentence one word at a time, in order. Self-attention lets the model look at the entire sentence all at once and understand how every single word relates to every other word all at the same time. That ability to process in parallel is exactly what allowed these things to scale up to the mind-boggling size they are today. And for images, the big breakthrough was something called latent diffusion. Instead of trying to manage millions and millions of individual pixels, these new models work on a much smaller, compressed version of the image. Think of it like working with a really detailed blueprint instead of trying to build the entire skyscraper at once. This huge leap in efficiency is the reason you can now run incredibly powerful image generators right on your own computer. Okay, so we've got the foundations, we understand the tech. Let's talk about the real world. How do we master this powerful tool? What are the risks we need to watch out for? And how do we even begin to think about the future? This quote absolutely nails the most important skill for using modern AI. These models aren't like calculators. They don't give you the same exact answer every time. They think in probabilities. So to get consistently great results, you have to guide them. You have to give them structured, logical instructions. And that is the art and science we call prompt engineering. And this goes way beyond just asking a simple question. There are some really sophisticated techniques. For instance, with chain of thought prompting, you don't just ask for the final answer. You ask the AI to show its work first, to explain its reasoning step by step. And it turns out that dramatically improves its accuracy on tough problems. Learning techniques like these is what separates a casual user from someone who can really make these tools sing. Now, on the professional side of things, this has really created two critical roles. You've got the data scientist. They're the innovator, the one experimenting and building the new models. And then you have the machine learning engineer. They're the builder who takes that innovative model and makes it actually work reliably for millions of people. One is about the spark of an idea. The other is about turning it into a rock-solid product. And if you want to know what businesses really value, well, the market sends a pretty clear signal. There is a huge salary premium for machine learning engineers. And that tells you something important. While coming up with the model is the innovative spark, the real, tangible business value comes from the tough engineering work needed to make that spark into a dependable, scalable product. But of course, all this incredible power comes with some very real risks. First, these models can pick up on and even amplify the biases that already exist in their training data. Second, that black box problem we talked about makes it incredibly hard to hold these systems accountable. And finally, generative AI has made it almost trivially easy to create incredibly convincing deepfakes and misinformation at a massive scale. This all leads to this fascinating legal mess right at the heart of the industry. So on one hand, the input, all the data used to train the models, is getting hit with massive copyright lawsuits. But on the other hand, the output, the new stuff the AI creates, is generally considered not eligible for copyright at all because there's no human author. It's this huge, unresolved legal gray area. So where does that leave us? AI is here. It's an incredible intellectual force multiplier, and it's already changing everything. The debate is moving on. The central question we all have to face now isn't if we're going to use this technology, it's how we are going to choose to govern it.
InfoTech AI 360.